José Luis Mas is a professor of applied physics in the University of Seville in Spain. He accumulated about 23 years of experience in the fields of environmental radioactivity and the analysis of trace or ultra trace elements and isotopes in environmental samples. His main research interests are focused on the development and application of these techniques to study processes such as ocean and air masses circulation, paleoceanography, soil erosion, sediment transport, and the environmental impact of industrial activity.
Thank you very much for this invitation and for having the opportunity of knowing something about this program. So once again, thank you very much. Let's see why it could be interesting to have some idea about the trace element accumulation in several biological species from the northern Benguela Upwelling systems. As you know, because I assume this picture is relatively well known, there has been due to the very high nutrient load of the Benguela Upwelling system, this part of Namibian coast has a very large productivity, and as a consequence, it is also characterized by a very good fishing bank. So that means that after the Second World War, there was a very huge increase in the catches at the industrial scale, and for some species there was some decline by 1970 as a consequence of the decline of the population of several of these species, such as anchovy or sardine, etc. So that means, during the, after the independence of the country in 1990, the Namibian authorities have focused their attention in trying to recover several of these species and were extremely careful with the and watching about these industrial catches. So at this time, it is a very important part of the of the GDP, a very important part of the exports. If we consider commercial fishing and fishing processing in Namibia and agricultural forestry, it's almost a third part of the job of the country. And from a social point of view, it is very interesting to see that despite the fact that as far as I know, the consumption of fish and seafood is not very popular in Namibia out of the coastal areas, despite the coastal population is relatively small, it is a very important part of the diet. These very rich waters allowed also the rising of the aquaculture farms. For example, oysters, both for export and local consumption, or mussel, we can see here the size. But also the production at industrial scale of seaweed. Seaweed is usually used in Namibia for soil amendments or animal feed. But also there are several Western industries interested in using seaweed for the purpose of producing biochar. Biochar can be used again for soil amendment, but also for carbon capture. Additionally, several species such as Gracilaria, which is used for the production of agar-agar, is almost completely exported to Japan, while some other species such as ulva or kelp are used locally for abalone farms. So the point is that we are talking about several species of seaweed, fish, seafood, etc., having a relatively complicated interaction with the water column, the sinking particles, and the sediments, including the resuspended particles and sinking particles. So that means that it is possible the transfer of several compounds, elements, etc., through the trophic chain, and this could affect in some way several of these biological species, including those of commercial interest. How efficient is this transfer depends on many factors, from biotic factors such as the growth state or reproduction state to abiotic factors such as environmental factors, or even the own biochemistry of the elements being under consideration. So in this work, we are going to focus mainly in the so-called essential elements and the trace elements. Also, from a categorical point of view, many of them are considered just as trace elements because their concentration in the environment are usually relatively small. The point is that several of these trace elements, once a certain concentration is overpassed, can produce both carcinogenic and non-carcinogenic effects. This is not a systematic list. And this means that several countries and international authorities have proposed several regulatory limits, both for carcinogenic and non-carcinogenic effects. And why this worry about Namibian coast? Namibian coast is assumed to be an almost pristine environment. Well, the point is that the industrial activities, especially mining, and the population has been increasing in a very important way during the last years. So if we focus, for example, in Walvis Bay, we can see that the population almost doubled in 10 years. And after additional 10 years, the population rises by another 50%. In the same way, the harbor or Walvis Bay has increased in size and especially in activity, because it is being used for export of mining products, for example, uranium, copper, zinc, etc. And this attention means that several years ago, a couple of years ago, there was a preliminary research in surface sediments, showing that several elements, here, for example, lead, zinc, and copper, were accumulated in very large concentration in relative terms, of course, near Walvis Bay. This sampling point is Walvis Bay. Indeed, if we go to the results in our sediment core, we can see that certain trace elements such as copper, arsenic, cadmium, etc., were more concentrated during the last 20, 30 years. So as a collaborative action between the Namibian authorities and the International Atomic Energy Agency, on what follows the agency, there was a sampling designed in order to have an idea about the background of certain trace elements in the northern Benguela Upwelling System. For certain biological species. In some cases, these were fresh data. For some other cases, as we will see thereafter, there was some kind of updated data. Additionally, we will try to identify the levels of concern for some certain trace elements, if any, and finally evaluating certain ecotoxicity risk associated to the consumption of marine biological species. So first there was done a selection of certain species of seaweed, mussels, and fish according to certain factors, such as how predominant they are in the studied region, how available they are for commercial use or export, their quality as bioindicator, for example, very important in the case of seaweed and mussel, and how representative they are of the local diet. We were trying to focus on certain elements according to previous studies in sediments, and this included elements having very different biochemical behavior, from elements prone to scavenging to elements theoretically being conservative in the water column. The sampling locations were located around the main Namibian coastal populations. That means Walvis Bay, Swakopmund, and Lüderitz. In Lüderitz, several points according to the distribution of aquaculture farms, etc. After the samples were collected and the pretreatment was done, they were sent to our laboratory in University of Seville, where they were submitted to a microwave closed vessel digestion, full digestion, and thereafter we did the measurements of certain trace elements, 15 trace elements by ICP and SMS. Something that it is important to remark is that when you are working with the agency, it is extremely important to be sure of the quality of your results. So we use the so-called United States Environmental Protection Agency, on what follows USEPA, 200.8 procedure, and of course that includes the replicate analysis of certain certified reference materials. The point is that how to do an interpretation of data could be relatively complicated because we are considering different species, different subspecies, different sampling locations, and several elements having very different biochemical behavior. For example, for this subspecies, maybe it is available in this sampling point, but not in this sampling point. So in order to summarize the data and in order to do a proper comparison, we use conventional analytical statistical tests using a conventional software devoted to that. This is me after removing my eyeglasses. For the assessment of health risk, we use the so-called THQ, which is an index defined again by the USEPA, which considers certain factors such as the concentration of the element. This is applied for the average concentration, for example, in mussel or in fish, or the median, depending on the data distribution. But it also considers the relative toxicity according to the IRIS database, which is available from the USEPA authorities. Also the time of exposure, and also the dietary intake, where the data were collected from the Food and Agriculture Organization databases. And to do that, we consider the same concentration of the same animal or whatever being consumed by people from United States, European Union, and of course, Namibia. Theoretically, in case the THQ for a certain element is less than 1, that means it is okay. It is okay means that it is not probable to locate any carcinogenic, non-carcinogenic effects during lifetime. For carcinogenic effect, we consider the so-called action limit values, which were proposed by United States authorities some time ago, and it is continuously updating. Oh, sorry. Once we have, let's see, once we have calculated this for every element, for example, for fish, or for example, for mussel, we can do the summation of all of this. And this is called hazard index. Theoretically, in a very good condition, that should be less than 1 also. So our results, we are talking about the concentration of 15 elements, so I'm trying to summarize. We did find that the trace element concentration were relatively small and were typical of unpolluted scenario for many of them, but not for all of them. Indeed, after application of discriminant analysis, it was possible to do a discrimination of the sampling area where the samples were collected. I mean, central part, which should be around Walvis Bay, and southern part, which should be Lüderitz, both for mussel and for seaweed. For example, for mussel, we can see, this is the discriminant function, we can see that for the minimum is in the southern part near Lüderitz, so the concentrations of cobalt and nickel in mussel were relatively small, and the samples collected near Walvis Bay were characterized by a higher concentration of both cobalt and nickel. In the case of seaweed, the trend was exactly the contrary, using different elements. In this case, the samples collected near Walvis Bay were characterized by a small concentration of both aluminum and zinc, while the concentration were higher for both elements in the part located, in the sampling points located near Lüderitz. So once we have these results, they are large, they are small. Well, in the case of seaweed, there were no problem from the point of view of any regulation that we have found for, especially for European Union. In the case of mussel, what we did was, in order to have an idea of how large or how small is this, is simply going to a worldwide database, having data from mussels collected around the world. And so it is possible to do a statistical treatment and defining certain percentiles. This dashed line should be the 50% percentile, and this dotted line should be the 85% percentile. And it is possible under these conditions defining a threshold contamination value. If the concentration of your sample divided by the TCV is less than 1, it is no problem. Otherwise, that means that the sampling region could be contaminated. So why am I marking here copper, zinc, and lead? Maybe you remember from our previous slide that we were talking about very high levels of these 3 elements near Walvis Bay. What is the mussel telling us about this? Mussel and seaweed. Well, what you can see here is a statistical distribution. In this case, you can see here the concentration in milligram per kilo, ppm, and these are the different mussel species: black mussel, Mediterranean mussel, perna, river mussel, and for seaweed the same: gracilaria, laminaria, and ulva species. So what we see in the case of copper, for example, is that the maximum were located, maximum are in red, in the southern part, I mean near Lüderitz, north Walvis Bay. Regarding the fish, the data were similar to other from the literature, so we can't speak about contamination in fish. If we go to lead, there are several interesting features. First, it was impossible to discriminate between sampling regions, and the concentrations were relatively close to the United States federal action limit, which is in the range of 1.7 ppm. What does it mean? This means that in case your concentration is above this level, United States authorities could retire this stock from the market. These 2 points in here, we can consider these as outliers, and they are actually the mussels of a smaller size. So it could be recommended avoiding having very small mussel exported to another place, for example, United States. In the case of seaweed, as you can see, no problem at all. Another important feature, there has some data reported by 2014 by Dams and co-workers regarding the lead concentrations, and these concentrations were systematically near Walvis Bay above this action limit. We have some doubts regarding the quality of the lead data in that study, both for lead and also for aluminium. For the other elements, I am happy with the quality treatment, but for these 2 elements, I have some data. It is important to see that theoretically lead shouldn't be a problem in case it is avoided collecting the smaller specimens. And for fish, again, no problem at all. If we go finally to zinc, we see again a maximum in the Lüderitz part instead of Walvis Bay area. Should be expected according to the situation in sediments. And for fish, it was similar to other data in the literature. So let's finish using the data for nickel, arsenic, and cadmium. Why? Because the TCV is overpassed for nickel for a relatively large proportion of the data. For arsenic, we will see why it is interesting, and for cadmium, it is extremely interesting. In the case of nickel, we can see maximum again near Lüderitz instead Walvis Bay. For fish, no problem at all. And in this case, we can see that the concentrations that were collected were systematically a few times less than the action limit, so no problem from the point of view of nickel. This blue circle here means that laminaria was the smaller concentration, the species collecting smaller concentration of these elements. In the case of arsenic, no problem. Again, with the action limit is much higher than the data that we have. And in this case, no clear discrimination. Simply in Shark Island, we collected the minimum concentration and the maxima were located near Swakopmund. And for fish, in this case, the data were less than other from the literature from the single species that we have used. In this case, mullets and sardine. And finally, for cadmium, well, in this case, the minimum concentrations were located near Walvis Bay, but a very interesting feature is that about 90% of results were above the action limits of cadmium. So that could be a relatively problem from the point of view of export of certain species of mussel. For fish, no problem at all, and for seaweed, as you can see, no problem at all. So how all of this is reflected in the toxicity, reflected in the THQ, reflected in the probability of appearing of non-carcinogenic effects? Well, all the values were below 1, so this is very good news with 2 exceptions. The 2 exceptions are for European Union consumers of fish. This is assuming that European Union are eating just fish from Namibia. And the only problem is arsenic. And arsenic in the case of mussel for the USA consumers. I mean, assuming all the USA consumers of mussel are simply eating mussels from Namibia, which is not true. If we go to the hazard index, we have divided the results in the consumption of pelagic fish, I insist, mullet and sardine, or mussel. For Namibia fish, for Namibian population, we can see that it is very close to 1. In the case of European Union for fish consumer, we can see that it is overpassing this level. It is not a regulatory, but simply an indication level. And we can see that for all of these consumers, the main contributors are lead, arsenic, and cadmium. Anyway, arsenic is a tricky result. I will tell you why. Regarding mussel, no problem at all for consumption with the data of Namibian consumption, intake, no problem for European Union. And again, in the case of United States consumers, it could be a problem being the main responsible of this, arsenic and cadmium. And as you can see, the other elements, when we consider the summation of all of them is really small. So why is this tricky? Simply because in the case of arsenic, we are considering that all the arsenic is in the oxidation state +3. You know that the toxicity of arsenic is depending on the oxidation state. We did no speciation studies, so we don't know what is the oxidation state of arsenic. One of them is relatively toxic. The other one is relatively easy to remove from the organism. So what we can conclude is that this theoretically problematic situation of the sediments, especially near Walvis Bay, has been not reflected in the biological species of commercial interest that we have analyzed. No relevant concentrations in seaweed, the same for fish. But the concentration of cadmium in mussels could be of certain concern, especially for certain countries having relatively strong regulation. Of course, we understand that the effect of arsenic is overestimated, and it should be necessary doing some kind of studies about the oxidation state. We think that the previous evaluation of lead are wrong, and as usual, additional studies are required. This was simply a first picture. So thank you very much for your attention, and especially for not sleeping during this time.
Thank you, Pepe. That was, I hope everybody understood. You were speaking quite fast, but I understood what you were saying. Because yeah, so is there any questions for Pepe?
Yep.
Yes, Chibo.
I also have quite a big data set of heavy metals and trace metals in seaweed, but like species wise. So the arsenic, the highest concentrations I found were in the Laminaria pelada. So you said, okay, from my understanding of what you did, because they tend to feed the Laminaria and over to the abalone. So did you do any measurements on the abalone to sort of see if it concentrates since
No,
it's feeding on the seaweed?
no, unfortunately not. You know, these results were first screening, so it should be very interesting trying to see what happens with the abalone, especially bearing in mind that abalone seems to be very popular for local consumption in Namibia. No, for this first study, we did not analyze the abalone. Anyway, my experience is that abalone is concentrating certain trace elements with less efficiency than, for example, mussel. So I assume that if mussel is not a very large problem, abalone shouldn't be. Shouldn't.
Yeah. Okay. Thanks.
Anybody else? Why is Kurt so quiet? Kurt?
It's I can understand that.
His hand was up. He's ready.
Okay, he's ready.
Okay, may I? Well, thank you, Pepe, for the nice presentation. I'm mostly interested in today we have high concentrations again of these heavy metals. There were times about 30, 40 years ago when they were very low, as you showed in the sediment archive analysis. What has happened at the time when those concentrations were very low?
Well, there are several possibilities from my point of view. First, I think that since 1970, maybe Deon can correct me, especially since 1970, there was higher and higher mining production. And mining production means that there is more pollution. And if we go to the potential sources of this trace element, we can see that there are Aeolian inputs from very far away from the coast. We have the ephemeral rivers suffering sometimes some floods, and some of them can come from the copper and zinc minings, which is some 70 kilometers from the coast. This is a possibility. The other possibility is, well, I was thinking about the potential natural origin of several of these elements, because many of them are being included with the micronutrients, and I think that especially in a place like Benguela Upwelling System, they could be exchanged through the trophic chain and finally going to the sediment as you know, abyssal not, but fecal pellets, productivity, skeletons, etc. So I think that there is a very funny combination of natural sources and maybe anthropogenic sources. Actually, the teams that were devoted to the sediment part were suggesting the possibility that due to the correlations of several of them, they were having the same origin. And for me, that suggests mining. For some indirect action, I think that some potential pollution from mining is arriving to the coast, but it is just
but you had it even higher also 150 years ago. So there something must have happened for a period of time where the input was rather low. Okay.
Yes.
But we take that for granted. That's the archive in the sediment that tells us that. we don't know what causes it.
Okay, maybe you can see this. This is a picture from a slide from Deon. I borrowed this. I'm sorry. So
no, it's fine.
You can see here the effects of this is the trital component of the sediment. So I think that some material could be especially with the aeolian transport be transported very far away from the inland. On the other hand, if you see to this other slide, this is from 1970. This is a relatively old picture, and this is a distribution map of several elements such as copper, nickel, lead, and zinc. You can see a maximum near Walvis Bay, and this was absolutely natural origin. By this time, as far as I know, several of the mining companies were not working, were not at the same level than now, and it seems that it was simply there was some kind of correlation with the organic matter. That means that it is possible that the accumulation of these elements is associated to the transport from Benguela Upwelling System and subsequent deposition several kilometers away northwards. Maybe this is a possible explanation, but it should be tested.
Okay, Kerry, I see your hands up as well.
I think I misunderstood, but did you say there are not rules on how much of these different metals you can have in mussels, and you're still allowed to sell them and eat them?
Oh, yeah. Okay. Well, the point is that several countries have established this kind of limitations, and so that means that when you are trying to get some stocks imported, there are several analyses on a routine basis. Sometimes the analyses are required by the people exporting the product. So they should. For example, our own laboratory has did this kind of work for some people from, I don't remember, Senegal, exporting calcium carbonate in order to show the Spanish authorities that the concentration of several radionuclides were below certain limits for import. That's the thing. So it is, for some point of view, we are telling the people that it shouldn't be a real problem, the consumption of several of these products, excepting in the case of cadmium. And in this case, it could be a problem, the export of this, unless assuming the regulations are the same than in the United States.
Thank you.
Anybody else would like to ask a question to Pepe?
Just a remark. It's a fantastic study that shows us how different elements get accumulated differently in different organisms. So that's a very beautiful illustration, because you have so many different elements and you looked at a number of different organisms.
Mm-hmm. Thank you.
Well, if there's no other questions, then Kurt is back to you.